Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is non-repeating character and it is an easy level problem. So the problem is fairly simple and I would say that it is actually an easier version of a problem that was the problem of the day a couple of days ago, and the problem is exactly the same. It's just that what we have to output is a bit different, and that makes this problem an easier version of that particular problem. And if you have not watched that video, I'll try to link it in the top right corner in the I button. You can also watch that video. So basically, if this is an easier version of the problem, then it opens up multiple paths to solve this problem. That means there might be many other possible ways to solve this problem. So we are going to discuss a similar method to what we did there, and we are going to solve this question in the required time and space complexity, that is O of n for the time complexity and the number of testing characters for the space complexity, right? So let me just explain you the problem. The problem says that we have been given a string of lowercase letters and we have to return the first non-repeating character in S. For example, this is a string, right? So in this particular string, some of the characters are repeating such that L, because you can see that L is present 2 times and the other 3 characters H, E and O are only present 1 time, right? So if these 3 characters are present 1 time, we have to output which came first among them, right? So basically we have to output any character which has occurred 1 time, and if there are multiple such characters, we have to print the character which was present the first among them, right? So this question becomes fairly simple. So there are actually 2 conditions. The first condition is that it should be present. It should be present once. And the second condition is if there are multiple of them, then output the first among multiple answers. So what do we mean by first? By first we mean that the character which came before all the other characters while traversing from left to right, right? So this is our whole question. Now how we can solve this problem? So we need 2 things. That the first thing is to maintain the frequency, right? We need to know what is the frequency of each character. So let's say I create an unordered map. Assuming that it is going to help us do all the operations in O of 1 time. So this would be an unordered map of characters and integers, right? So let's say this is my map. Now to store what is the first among such multiple answers, we need to maintain some kind of a data structure like a queue, right? So I'm trying to explain you in the same way that we solved that particular question. We are going to discuss it using the same method. So what happens inside a queue? Queue is always first in, first out. So the character which comes first will always be present at the front of the queue, right? So our logic is that whenever we encounter a character, we will first increment its frequency in our map, right? If our frequency, or let me just write map, if our map of I is the current character, is equals to 1. If any character has a frequency 1, that means it has now become a valid character. So I'm going to use this queue to store all the valid characters that I can have. So what I can do is I can just push this character into my queue, right? Once I have it in my queue, now no matter what other character comes after it, this element will always be present at the front of the queue. That means as long as it is valid, it will be the first element at the queue. Now there is one more thing that I want to do, and that is while q dot size, if you just write q dot size in C++, it would be accepted as true if it is a non-zero value. Otherwise, if it is a 0 value, it will be accepted as false, right? If the size of the queue is non-zero value and the front element of the queue, map of q dot front, the front element of the queue has frequency greater than 1, right? Whenever an element has a frequency greater than 1, that means it has become an invalid character and now it does not deserve to be in the queue anymore. This is what our logic is. This queue is only going to store the valid characters, and since the character at the front of the queue has become an invalid character, we're just going to pop that particular element from the queue. right? So this is as simple as it is. Now at the end, what we can just do is, if there is at least one element in the queue, then we are going to return that particular element, right? That will be stored in queue.front. Otherwise, we are going to return this $sign, which the question has asked us to return, right? So this is our whole logic of the question. What we are trying to do is, we are trying to maintain a queue which is going to store all the valid characters. How do we determine that a character is valid or not? We are going to determine with the help of this frequency map, which is going to store the frequency of all the characters in the string. Whenever the frequency of any character becomes 1, that means this particular character has become a valid character. So we try to push that particular character in a queue. Similarly, whenever the frequency of any element becomes greater than 1, we just try to pop it out from our queue. Right? These are the two operations that we need to do to make sure that the elements in our queue are all valid characters. Right? Now at the end, I can just return the queue.front if the size is non-zero. Otherwise, I can just return this $sign. Now, what about the time and space complexity? You will observe that the map will only have the number of distinct elements as its keys. So, the space complexity is O of number of unique characters for the map, and for the queue as well. The space complexity is the number of unique elements, because you will see each element, whatever element we have inside our string, will get pushed into the queue whenever its frequency is 1, and whenever its frequency becomes greater than 1, it will be popped out of from the queue. So each element will be present at the queue for at most once. The queue will not contain duplicate elements like this, right? It will only contain unique elements. So the queue will also have a space complexity of this number of unique elements in the string S. Now, since we are just traversing through the string and all of these operations are O of 1, we are assuming, especially for this particular unordered map, and for the queue it's always O of 1. So our total time complexity will be O of n itself, right? Now let us have a look at the code. So you see what I've done is I've created an unordered map and a queue of characters. Now I just traverse through the string. I increment the frequency of my character I. If its frequency equals to 1, I just push it into my queue. Otherwise, I check if it has a non-zero size and the element at the front of the queue has a frequency greater than 1, I can just pop it out from the queue. And at the end, I check queue.size. That means if it has a non-zero size, I'll just return queue.front. Otherwise, I'll return the $sign. Right? So this was all about today's problem of the day. Now let me just quickly submit this and show you that this particular code works. So you see, it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and to be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos are not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always subscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.